All right. Okay, so continuing where we left off. So we had last thing we did yesterday was we filled out this guy here. All right. It's the same thing as this, except it's a little more detailed, right? Because I told you yesterday they're going to ask you about different little slices, not the whole thing, just part of it. So having this will be a lot easier because calculating parts of this aren't, you can do it, but you would have to do the math again. And we did the math here. So, for example, we're going to do the first problem together. So, this guy right here. So, the top of the page on the first, the one I gave you yesterday. Okay. Normal distribution. Normal distribution. So, all normal distribution, we talked about that, looks like one of these two guys, right? Normal distribution looks like that. So, when we're doing normal distribution problems, when we're asking for probabilities or percentages, always do these 4 steps. Okay? You will get 1 point for each step. If you miss a step, you only going to get 3. If you miss 2 steps, you only get 1 or 2 points, and so on and so forth. So each of these questions on tests will always be worth 4 points. Each of these questions here that we're going to do together. Okay? So the first thing you got to do is draw and label a normal curve. That's the first thing. Okay? Uh, draw a curve, label it. We'll do it together. We'll do some together, but we're going to do all of these steps together. Shade. So they'll either say what side. They'll say shade greater than or less than or in between. They'll always tell you where. Okay? Then we're going to use z-scores and your tables. That's where we're going to use your tables to actually answer the question. And then the fourth step is just as important because you have to actually interpret it. What does it mean? You're going to get number 3 will get you an answer, but what does that answer mean? That's step 4. Okay. So let's do the first example together. Okay, so the mean weight for an adult female walrus is 112 kilograms. Okay. They have a standard deviation of 67 kilograms. Okay. Weights follow normal distribution. So because we see this, we don't have to check. We don't have to check anything like we did yesterday. Remember, we were checking our heights and the heights for the other classes for these things to see if they fit in here. We don't have to do that because they've told us, hey, we've done that for you and it's normal. Okay. That means we can keep going. We can go on to actually solving the problem. So the first thing we're going to do, it says, actually this one says, draw and label the normal model for these female weights. So the first thing we're going to do is we're going to draw a normal curve. Do the best you can now. You'll get better at this, but just do the best you can. So the normal curve is going to look like this. Okay, and then it's got a line underneath. Just do the best you can to sketch that. Doesn't have to be perfect, but it gets the job done. Don't make it messy, but it doesn't have to be perfect. You'll get better as time goes on because we're going to be doing practice on these types of things. And this is always a step. Okay. So when they say draw and label, that means draw it. So we drew it, label it. So when we're labeling, we always start in the middle. The middle is the mean. So for adult female walruses, the mean is 812. So we're going to put 812 in the middle. Okay. So kind of like what we did yesterday with the heights, when we went out one and out one, remember that when we did that? We're going to do the same thing, but for this problem. Okay. So if I was to go out a standard deviation, what would the weight be? How would I figure that out? Take 812 and add 1 standard deviation. When you do that, what do you get? 879? Good. Okay, so how about for this guy here? Subtract 1, right? So take 812 and subtract a standard deviation. What do you get? 745. Okay. Now we're going to go out another one. This is 2 standard deviations. So you can either multiply 67 times 2 and add it to 812, or you can just add another 67 to 879. It's the same thing. Okay? So what do you get when you do that? 946. Okay. And then again, you can do the same thing. You can take 2, multiply 67 times 2 and subtract it from 812, or you can just subtract another 67 from 745. It's the same thing. And you'll get 678. Thank you. And then we got to go one more. One more. It's just going to be 1,000 something. 1,013. And then 609. 11. 11. There we go. That's strongly. You don't have to do different colors. I did different colors just to show them. But that's what drawn label means. Drawn label means drawn label, right? Drawn label that so that I know the mean is 112. Let's say I didn't have this up here. Let's say I didn't know this guy up here. I could still figure out a standard deviation because I could figure out the distance in here. Just subtract these guys, right? So it tells you everything without, by looking at the picture, it tells you everything. Okay. So now we're going to use this guy to answer the question below. What proportion is between 812 and 879? So this is where the shading comes in. This is what you're going to do here. You're going to shade the region they want it, shade the region in question. Okay. So I'm going to make a copy of this. Copy. Okay. Just shade yours. So where am I going to shade it? I'm going to shade it from 812 to 879. And I'm going to shade it right there. All right. You could figure it out on your own, but didn't we just do that? Don't we know the distance between the center and 1 standard deviation above? We just did that, right? We did that yesterday. Right here. The mean and 1 standard deviation above. The percent in there is right here, 60 or 34. 34%. So they use the word proportion. You see how they use the word proportion? Proportions we usually write as decimals. So they want 34% as a decimal. How do we write 34% as a decimal? 0.34. So we would say, let me move this a little bit to the left. 0.34 of female walruses are between, or we can just say, instead of between, we can just say 812 or 812 to 879 kilograms, or weigh, I should say R, weigh. That's step 4. Step 3 we didn't do for this one because it came straight from our, we'll do step 3 later. We're going to do step 3 a lot, but not for this one. We didn't need to do it for this one because it came from our graph. Okay. Okay, I want you to try step C, or do letter C. Do letter C. If you need to draw and label it, draw and label it. Or if you want to just use the one you used up there and shade it, that's fine too. So that is the side that what I shaded there at the edge, that little tail there, that's what I want to know. Those two percentages I want to know. So I go to my table that I did yesterday and I look for the same area. It's this area right here, from 2 standard deviations all the way to the edge. That's what I want to know. I want to know from, because this is the mean, this is 1 standard deviation, 2 standard deviations, from 2 standard deviations all the way to the edge. Those are the two percentages that I want to know. So one is 2.35% and one is 0.15%. So I add those two guys up and I get 2.5%, 2.5%. So I would say 0.025 of female walruses weigh over 946 kilos. Very few of them weigh that much. Okay. Then they're going to do this. They're going to kind of change the way they do the question. Still applies. D, we're going to do exactly the same way we did for B and C. Exactly the same way. But they always do this. B and C are more kind of, yeah, I know what to do. D is kind of a critical thinking question. You got to kind of think a little bit, but it's exactly the same. They want to know, how much does a female walrus have to weigh to be considered skinny? Okay. Skinny for a female walrus. What they consider skinny is the lowest 16%. The lowest 16%. Okay. That's what they consider skinny. What side are we going to look at? The left, the very far left. We're going to start from the very far left and we're going to count until I get to 16%. So go all the way to the far left and count the zones until I get 16%. Once I get 16%, I'm done. So you're going to go 0.15 plus 2.35, that's 2.5. We got to keep going. Plus 13.5. What do you get when you add those up? 16. So we're going to stop right there. That's the guy we want to stop at. Which number is that on ours? There you go, right? It is 745. 745. This is where we stopped right here. So to be considered skinny, they would have to be in here. So what's the most it can weigh to be considered skinny? 745 kilos. 745 kilograms. Anything less than that? So you could also put this. Sometimes you put little symbols. So at most, you could put at most 745 kilos. They can't go over that because then they go into the next group. That's too much. Okay. Again, it's the same thing. Did I use this guy here? Yes. Did I count? Did I find the zones? Yeah. But it's just, it was a different, the way they worded the question, it was different, right? That's what they always do. They're always going to do that. So you just got to kind of think about what you know and try to figure out what you don't know and use it. Okay. All right. Do I have another example here? Okay, so let's go to the next page. All right, so a couple reminders about the normal model. Remember, the whole thing is 100%. So from edge to edge, from here, from here to here is 99.7. But it includes this part too. This part too, if I include all of these parts, it's 100%. Okay? In theory, it goes forever, right? In theory, this goes forever. So in theory, this curve never hits this line, in theory, because there could be someone, there could be a walrus who weighs however he knows pounds. Or there could be a walrus on the other side who's very, 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 very skinny. There could be. We don't know, right? So that's why, in theory, it goes on forever. Okay? All right. So we're going to, now what happens if we can't use that rule? What happens if, this is what's going to happen. I'll show you what's going to happen. They're going to give you the walrus question, but they're going to do this. What is the probability that they weigh 820 pounds or more? 820 pounds or more. How do we do that one? 820 pounds. Well, where is 820? Right there, right? Or more means we shade this side. Can I use my graph that I made yesterday to do that? No, why not? Because it doesn't go all the way to here, right? So every value that's in between, I can't use that the way that I've been doing it. So what do I use? Well, you're going to use the tables that are in front of you, those tables that you have, that I gave you yesterday. Okay, so we're going to use the tables on A right now. So let's set it up. Let's do step 1, step 2. Step 3 is where we'll use the tables. I'll show you how to use the tables. They're really easy to use. They look super complicated, but they're really easy. Okay, so let's do the next example, A. Let's set it up, and then I'll show you how to use the tables. Okay, so it's the same premise. Adult female walruses' weights are approximately normally distributed with a mean of 812 and a standard deviation of 67. Same premise, right? So if we were to select a female walrus at random, what is the probability that her weight is more than 780? So the first thing we always do, draw and label. Draw and label. So I'm going to draw a normal curve. We don't have to label as much on these. We don't have to label as much on these. I'll show you what I mean by that. So we draw our curve. Always label the mean. 812, right in the middle. Now we don't have to label anymore. All we have to do is label the parts that we know and the parts they've given us. So we know that the mean is 812. What is the question they're asking? 780. So we have to graph that. So 780 would be roughly here. Roughly there. And then what about 780? What side do we shade? Left or the right? The right, because it says more than. More than means over here. Now we can't use this guy here because where does 780 fall between? Where is 780? 780 is like right about there. It falls kind of in between them. Is it directly in the middle? Is it, where is it? I don't know. If it falls in between, I can't use this guy here. So this is why we give you, I have another option, okay? So the other option is to use what we call z-scores and the table. Okay, so we've done step 1 and step 2. So now what we got to do is come up with a z-score. You guys remember the formula, right? What's the formula for a z-score? Z equals observed minus the mean divided by standard deviation. It's the same formula. You've used it before. Okay? So what I'm going to find is I'm finding the z-score for 780. I'm going to find the z-score for 780. So the z-score for 780. At 780, what's the observed? What's the observed weight? Not 812. That's the mean. 780. The observed is always what the question we want to answer. Minus the mean, which is 812, over the standard deviation, which is 67. So we go to our calculators and we crunch some numbers. So do subtraction first and then division. Because your calculator, sometimes it knows PEMDAS really well and it does things you didn't mean it to do. So do subtraction, you get negative 32, right? And then divide it by 67. This is the only time we're going to go 2 decimals. Only time we're going to go 2 decimals. Every other time we're going to go 3. I'll explain why in a second, why we're going to do that. But only 2 decimals. So 4, 8. 4, 8. Most of the time, every other time, we're going to go 3. The reason we only go 2 is because of our tables. Okay? I have a question. What's the z-score for 812? Without doing any calculations, what's the z-score going to be for 812? 0, yeah. The z-score for 812 will always be, or the z-score for the mean will always be 0, because the first thing you do is subtract it from the mean. So this is what I do next. I write the z-scores in. This z-score is 0. This z-score is negative 0.48. Okay. Now we're going to go to our tables. So what I want you to do is go to your tables. So we have there's 2 sides. I only want the side that looks like this. The 2 pictures in the front. So match the side where it looks like this. The other side we'll use second semester. This side we're going to use this semester. So I'll teach you how to use the back side, but not today. Next semester I'll show you. This is the one we're going to use. So you notice on the left, so there's 2 z-score tables on one. There's the left side and there's the right side. So over here, I'm going to highlight where the z-scores are. So the z-scores are over here. The z-scores are over here. And over here. So what I want you to do is go find our z-score. What was our z-score? It was negative. So where are the negative z-scores? On the left side of the table or the right side of the table? The left side. Yep, we're going to be over here. So we're going to be on the left side. It was negative 0.48. So you're going to go down until you find negative 0.4. I'll use a different color. Here it is right here. Blush. Okay. Now we have to combine that with 48, 0.8. 0.8 is up here. Negative 0.4 positive 0.08. When I combine them, I make negative 0.48. So now what you're going to do is figure out where they meet. Go down, go over here. The decimal where they meet is what I want. Right there. That's the number I want. 0.3156. 3156. Okay, that's the number I'm going to write down on my paper. That represents a percent. What was it, 3156? What percent does that represent? What percent does that represent? What percent? Huh? 31.56%. Yeah. Okay. Here's the question here, though. Here's the question. I have some that's in blue, and I have some that is not covered at all. Which one does this go with? Does this go with the non-shaded side or with the shaded side? It goes with the non-shaded side. It's not going to go with the shaded side. There's a couple ways you can know that. Doesn't this look pretty big compared to the whole? So 31% is not more than half. 31% is actually less, right? So this should be this. The other way to know is that our tables, all of these percents, all of these guys in the center, start from the left. The z-score table always starts from the left. It always starts from the left. So from the left, from here to here, that's the percent it gave me. That's the decimal it gave me. Always. The z-score table will always do that. Okay, sometimes we want that side, sometimes we don't want that side. So you just got to know what side to do, what side you want, and what side it gives you. So I still haven't answered the question though. What about this side over here? How do I figure that out? The area is always going to be this, the total area. I know that this part over here is this. So subtract it from 1. So we're going to go 1 minus 0.3156. That'll give me that side. 0.6844. That's the one I want. Okay? Be careful, because on a multiple choice test, 0.6844 will definitely be on there. But which other one will be on there too? This guy too, right? So if you don't remember, it starts from the left. Z-score table always starts from the left. Z-score table always starts from the left. So anything you get from the table is going to start from the left side, like a book. Like you read a book from left to right, that's the way a z-score table reads it too. Okay? You don't have to, I don't expect you guys to memorize this at all. Don't memorize it. I will give you one on every test you have. From the rest of the year, I will always attach one to a test. So you got to know how to use it, but I will not make you memorize anything about this. The only thing you have to memorize is this is the side I'm going to use and how do I use it. Okay, you don't have to memorize the numbers. That's why I gave you the table. Okay, you just got to know how to use it. All right. Okay, so here we go. Let's go back. So we did step 1, draw and label. We did step 2, shade. We did step 3, z-scores and tables to calculate a probability. That's our probability right there, 0.6844. The last thing is, what does that number mean? Okay, this is what we're going to write. That's what this, it answers the question, what is the probability? So we write the probability of selecting an adult female walrus more than, so I'm going to use greater than 780 is 0.6844. The probability of selecting an adult female walrus greater than 780 kilos is 0.6844. That's what it means. It answers the question. They asked us, what is the probability? What are the chances? That's the chances, about 68.5%. Better than average. Okay. All right. Those are all 4 steps. So that's how you go through the 4 steps. So let's do B together. Let's do B. Let's do the next one together. B. Okay. So again, if we select a female walrus at random, what is the probability? The weight is, this time it's less than 600. Less than 600. So let's draw and label. Draw and label. Draw, label the mean, and label what we know, 600. And then shade it. Hold on. Okay, so the mean is always start off with the mean. The mean is the same for this one, it's 812. The question said less than 600. So I'm going to label 600. Give me a second. I'm going to make this a little smaller so it doesn't run into the next. Okay. So we have less than 600, right? So 600 is over here. Less than means we shade to the left. We have to find that percent there, or that decimal there. That's what the question is asking. Okay, so we did step 1, step 2. Step 3, we got to use z-scores to come up with the z-scores in the table to answer the question. Okay, so the z-score at 600. The observed is 600 minus the mean, 812. Then we had divided by 67. 600 minus 812 divided by 67, I get negative 3.16. That's the z-score. Go and label. Okay. Go to the tables. Go to the tables and find a z-score. It's another negative z-score, so it's going to be on the left side. Find negative 3.1 on the left, 0.06 on the top. Okay. See if you can find it. Go find it now, and I'll find it in a second, and we'll see if we get in the same spot. Okay, so it was negative 3.16. So negative 3.1 is right there. And then I need a 0.06. That's my guy right there. Very, very small, 0.0008. Very, very small. Okay, so I'm going to go back here. Now here's my question. Is it the left side? Is it the shaded part? Or is it the blank part? because we always start from, the z-score always starts from the left. The z-score always starts from the left, so I don't have to subtract on this one. That's the number. What percent is that? 0.0008. 0.08%. Yeah, not even 1%. Not even 1%. If I cut up a penny into 100 pieces, it's not even one piece. That's how small it is. Okay? Very, very small. So the chances, so let's finish it out. Use the sentence frame that we used earlier. The probability of selecting an adult female walrus, this one is less than 600 pounds or 600 kilos, is 0.0008. Pretty much nothing. Pretty much no chance. Pretty much no chance. So if you randomly saw a bunch of walruses and randomly picked one, the chances that that walrus, female walrus, is less than 600 kilograms is not even 1%. Okay? Does that make sense with the question? Does that make sense? Does that probability make sense with kind of checking your answer? Does it make sense with what we're 600? Look at 600. Where is 600 on this original one that I made? Way out here. As you get farther and farther from the mean, what happens to the tails? They get very, very small, right? So anything out here is going to be super, super small. Super, super, super small. Okay? So that makes sense. That makes sense that it's going to be small. Okay? All right, so let's do letter C. These are all of these questions. That's the nice thing about chapter 2. All of these questions are essentially the same type of question, but they ask them differently. That's the thing with chapter 2. They're all essentially the same question. They're just worded differently. Like this one is different. What's different about letter C than the last two we've done? It's in between. Yeah, it's in between. We haven't done in between before, so we're going to do that one right now. Okay, so let's do in between. Here we go. First thing I got to do is draw and label. Start with the mean. It's still 812. This one has two numbers. Well, I got to graph both of them. 720 is over here. 785 is over here. In between those two. So my shaded area for this one is actually going to be in between. It won't be on the edge like it was on the last two. It's actually in between. That's what I want to know right there. In between. So this one involves a little more work because it's in between. So this is what we're going to do. This is what we're going to do. Watch me. Watch eyes up here. I'm not going to do any calculations. I'm just going to show you visually what we're going to do. This is what we're going to do. We need to find the piece in the middle, right? So we're going to find the area of all of this. That's the first thing. And then we're going to find the area of this. And then what are we going to do with those two numbers? Subtract them. You got it. So it's essentially kind of doing the same thing twice and then subtracting whatever you get. We're going to start with the whole, or the big piece. The big piece is this. So what z-score are we going to look for with this guy when I'm looking for this? 785. So let's do that. Z-score 785. 67. Here. Okay. So I got a z-score negative. Does it make sense that all of these z-scores are negative? Does that make sense with what we're doing on the problem? Because why? They're all below the mean. Everything we're doing is below the mean. So yeah, we're going to get negative numbers. Okay. So what percent, or sorry, what decimal do you get on the table with negative 0.40? So we get 0.3446. 3446 goes from the beginning, the left side, up to 875. It goes there, right? That's the big piece. So that's not the middle piece. Okay. So now I got to find this little piece here. So I'm going to use a z-score. I'm going to use the, now I'm going to find a z-score for 720. That'll give me the little piece. I get negative 1.37. So now go to your table. Negative 1.37 gives me a z, or gives me a decimal of what? Okay. So 0.3446 is the answer if I said less than 785. If I said less than 785, that would be my answer. 0.0853 would be my answer if I said less than 720, right? But that's neither of those I want. I want the part in the middle. So what am I going to do with both of those? Subtract them. And what do we get when we subtract? 0.93. That's the part that I want. Last step, put it in a sentence. The probability of selecting a female walrus in between, so I'm going to use 720 to 785 kilograms, is 0.2593. Okay. You know what? IQR. Yeah, this one we got about 9 minutes. It probably will take us close to that, so I don't want to cover that part. We will finish that. We'll finish. I'm going to give you some practice. So on Monday, or Tuesday, this is what we're going to do. We're going to do this problem. I'm going to have a couple practice problems for you guys to play with to get better at it, and then the rest of the time I'll probably give you to start your assignment. Okay, because we're done. There's a practice problem there, but that's pretty much it. Chapter 2 is very short. Okay, so we'll have time to next week. We'll definitely finish the chapter next week. Okay.